Okay, so I'm looking at solo attempt number 1 for lesson 8. Let's start by getting these different times plotted. We have the amount of time it takes students to get to school in the morning and how much time it takes them to get home in the afternoon. So we already know we have one student. It takes 11 minutes. Oh, this is the afternoon, so I have no one. That's already a mistake. So let's just go ahead and switch. No, this is morning. Here we go. Afternoon right here and morning right here. So we have 1 at 11, 1 at 12, 2 at 14, 1 at 16, and 1 at 17. For the afternoon, we have 1 at 6 minutes, 1 at 10 minutes, 1 at 13 minutes, 18 minutes, another 1 at 18 minutes, and 19 minutes. So we're instructed to first find the mean of the amount of time it takes students to get to school each part of the day. So we're going to show our work, but we're going to use a calculator. So let's start with the morning, which means I need to add 11 plus 12 plus 14 plus 14 plus 16 plus 17. I'm going to divide that by 6 because there's 6 total numbers. So let's go ahead and figure that out. So this is the kind of thing where you should have this work shown, but then the following work can be done with a calculator. So I can add those numbers up, 11 plus 12 plus 14 plus 14 plus 16 plus 17. Get this divided by 6. Now we get 14 for the mean, or about the middle time, which makes sense because this looks like the middle right here. Okay, so let's do it for the afternoon now. And for the afternoon, I need to add 6, 10, and 13. And then 2 18s and a 19. And again, it would be 6 numbers. So I have 6 plus 10 plus 13 plus 18 plus 18 plus 19. Again, divide that by 6. Both have a mean of 14. So let's look and see what that suggests. So here's our mean values. Put in those dot plots. So it asks you what is the mean time to get. Oh, I guess I did. Whoops! I did A and B together. So all this work right here should be moved down here. And now we can actually start to think about it. For each distribution, or for which distribution, does the mean give a more accurate indicator of a typical time? Explain your answer. Okay, so let's think about this. It looks like more of the times are closer in this one, and they're further spread out in this one. So that would mean if they're all closer to this one, the mean is better for the morning time. So here's a piece of evidence I could say. I could say in the morning times, the values more closely surround the mean value, the mean of 14. In the afternoon times, the values are more spread out. From the mean. Therefore, the morning mean is a better indicator of a typical time. Let's think about why that makes sense. If I said about, and that's about what I should say there. So if you didn't get that, make sure you've got that. And let's think about why that makes sense. If I said, oh, well, how much time does it take you to get to school in the morning? You said, oh, about 14 minutes. Most of these are pretty close to that. Only 3 minutes away, 2 minutes away, 2 minutes away, or 3 minutes away. But over here, there's such a bigger difference that, of course, the mean makes more sense for the morning times.